Grays Engineering and Mine Surveying. I was previously employed by a contract earth mover here in Perth and engaged to take on one of their failed rehabilitation projects. This particular pit was outsourced to a contract earth mover to be mined and rehabilitated. It's situated in Perth's jarrah forests, one of the last jarrah forests on the planet, and adjacent to Perth drinking water dams. An extremely high risk and very environmentally sensitive region. The area is extremely steep, sitting in around about 16 degrees natural terrain. The contract earth mover was engaged to mine out all of the pit, and they approached the asset owner and said to them, look, it's extremely steep, we don't think we can mine it and rehabilitate it unless they provide them with a mine rehabilitation designed to meet the strict environmental criteria. They were unable to achieve the required outcome and abandoned the ore and rehabilitated it over the top. A couple of seasons later, the rehabilitation failed, and a lot of sediment was washed off into the bush, and they've had to revisit the rehabilitation area. As you can see from the aerial footage from the drone photos, there's several areas where the rehabilitation had failed, the most prominent being in the northeast corner, where they'd had a very heavy winter, and a lot of the topsoil had run off into the forest. I was approached to provide them with a mine rehabilitation design which met some strict environmental and gradient criteria, and using Global Mapper I was able to provide them with 3 design options which facilitated not only rehabilitation at the strict criteria that was required, they're also able to recover around about 90% of the abandoned ore, which more than paid for the rehabilitation, re-rehabilitation of the project. The pit itself is situated within 400 metres of Perth drinking water catchment and within 100 metres of the stream zone, so quite a high risk location. Okay, as you can see in 3D from the aerial imagery and subsequent background LiDAR, there were several areas there of extreme erosion. Some of those gullies had washed out in excess of 1 metre in depth, and you can see the final erosion point down here, which had washed out into the forest. And you can see from the location, very hilly terrain adjacent to the dams and stream zones, as I say. And in this case here, we were able to achieve a really good outcome. I'll show you the relative output thereafter. And this is what we were able to achieve, a very geomorphic rehabilitation design, post ore extraction and rehabilitation of the area. We had, as you can see from there, we actually encountered some granite which we were unable to remove due to the size. We had to redesign around it, several habitats in pit, and it's met all of the gradient criteria and the subsequent water capacity holding requirements within. So cleaned up and rehabilitated the remainder of the pit there, but the primary focus, as you can see there, is within the turquoise line. That was the area we're engaged to clean up. But overall, a very natural looking rehabilitation area, and in years to come you won't even know that they were there. Okay, now I'm going to run you through preparing your data and using a combination of LiDAR and photogrammetry data. In this particular project I requested a recent and up-to-date drone flight, of which I was provided with a 1 metre XYZ file and a ECW, and a clearing outline which had been physically picked up by a handheld HP GPS in field. As you can see from the data, most photogrammetrical data is good where there's sufficient image overlap, and you can see the large tiles that are created outside. Also, you get a lot of overlap from the trees hanging over the data set, So I like to clean up my data set before I start using it. So Global Map is really good at that. I create an area feature from my string file that I supplied, and just simply use the cropping tool here, and you can crop to the currently selected polygons, which helps me clean it up really quickly. I then overlay it with LiDAR data, which I'm supplied, and then export that out as a GeoTIFF itself. So I use the file export elevation grid format in GeoTIFF at the nominal grid sizes. In this case, I'll just make it 0.1 and 0.1, 32-bit floating, and just use the draw box to window around the data set just to get a larger, nice clean tile that I'm going to use for my works. So in this case here, I'll just call it my grid. Export that out and bring that straight back in. So there we go. Okay, from here I've got my working grid and my previous survey. Turn off all the others. Now that gives me something to work with. I've got a nice clean data set to kick off on. So generally I'll start with running my watershed. I'll show you how I do that. And conduct a general drainage assessment. So usually I'll run a watershed on a 1 meter grid, and this is very good to check the quality of your data set too. Make sure there's no zero errors, because all of those washouts should align, as you can see, which they do. Global Map is very good at picking up these drainage channels and showing you where the spill points and overflows are. And you can see the erosion scours the watershed aligns beautifully. So it gives me some confidence in the quality of my data set before I start working with it as well. I then conducted an overall drainage assessment. So I use the water tools. Generally I'll use the vertical options, and I'll just hover over the data set here. I'll get an idea of around about 260.4. Input that here at a 1.1 meter increment, and I can start to flood my data set up from the tree line. I'll just raise it up in generally in 100 millimeter increments until I can completely flood the pit. So in this case here, I've got a very small pond down there, probably insufficient to worry about. My next big one's going to be around about here, so I'll create one at the 274.6 mark. And raise that up until it floods. Okay, I can see it appears to be roughly my overflow point. Then I'll back it off, create a contour at that point. You can see when if it creates a series of contours, you can simply copy that. Select the one you want, Control Copy Paste, create a new layer, and delete the old one, and I'm just left with the one contour that I want. Now, whilst I've already got that selected, I'll immediately select the Create Area feature tool. And I'll create an area feature from it. In this case, I'll create a series of ponds, and I'll just call that my layer ponds existing. Now, I can immediately create a DSM from that. If there's multiple ponds, I can do them all simultaneously, but I'll just show you how I use the attribute tool, the feature attribute table. Usually I'll dock that in my working area, and you can create multiple DSMs from this all at once. So by selecting the area features, I'm going to create a series of DSMs. I can do them all at once. In this case I've only got one, but for the purpose of this exercise it'll suffice. Okay, I've created a DTM for the top of that pond, and I can do multiple volumes at the same time. So in this case here, I'm going to measure my volumes. I'm going to do them all at the same time. Do my ponds versus my grid, all cropped within the area features, and it pastes it all into the attribute table. So I'm able to add additional features to this particular attribute table. If I want to do, for example, introduce a floor elevation, I want to know that from the depth of the pond, I can include that. Catchment areas, I might have my catchments associated with that particular pond, and I can do some string maths in here as well. So for example, if I wanted to know the floor RL of those, I can use the attribute table feature here, and in this case I'm going to calculate the floor elevation. It's going to be relative to the elevation of the pond, and I'm going to subtract the maximum ZD in this case, and it'll automatically calculate all of the depth, the floor RLs for my ponds here. It's a really good way of computing your the pond volumes, etc. So now that I've got an area feature associated with that, I can also use the other features which Global Mapper has, which I'll show you now. So in this case here, I'm going to run a watershed analysis on my contour, so you have to have them selected. I'll now run the watershed tool. And this is going to be on the 274.4 metre contour. And this will calculate the catchment area associated with that particular contour. I'm just going to do it at 1 metre, and I'll let that do its thing. Okay, we've got the first of them through, and I'll repeat this process once again using the watershed at 260.3. So turning on my watershed here, 260.3, apply. And in this case, we're only going to have a very small capacity pond, but I'll use it to run the watershed nonetheless. I'll first create a contour at 260.3. And once again, I'll copy and paste that one, Control V, Control, create a new one. Get rid of the old one, and I'll run my watershed on. And that one's much quicker. So from there I'm able to determine the actual catchments of each of those ponds. I generally copy and paste them into a new layer of their own. Call them catchments existing. Turn off my previous, and I can then use my area feature tool to crop the remainder. So I've just got the catchment area within the clearing line. I like to change my colours a bit, make it a bit easier to see. and use the transparency tool so I can see the underlying. I also like to use the vertex editing tool, and I can smooth those and simplify them. This gives me a much more natural looking product. If you want to clean up and trim out outside of that, you can actually use the crop tool for that as well, by cropping and keeping the information or data outside, I should say. It's a very quick way of getting your catchments. And there we have it. We've got the subsequent catchment areas for both of those with the associated watershed. We run the watershed separately, so I've got the 2 metre watershed lines or 1 metre watershed lines. And I just used a spreadsheet to calculate the relevant volumes relative to the 960 cubic metres of capacity for each. And then you can work out the remainder. So working through that and just sort of building on it, you can ultimately end up with a complete sort of analysis of each, where you can see the watershed lines and break up your catchment areas accordingly. And then you can work out your relative 1:100 year rainfall event criteria. Okay, so generally before I start doing any design work, I'll put a plan together. I'll print out a scaled map in A3 or A4, take it out in the field and physically walk the area to be rehabilitated. I'll take some sketches and notes and draw them on the printout itself, and generally I'll take a photo of that out in the field, send it back to myself, and I'll use that to digitize it in Global Mapper, and generally I'll use that as a starting point for my design work. So when commencing my design process, what I do is I calibrate the field sketch in Global Mapper, and when you've taken a photo of it and sent it to yourself, it'll generally be in a JPEG format. You can drag and drop that, calibrate it within your screen, and use that as a starting point for digitizing. Then I'll generate some contours from my existing surface, define my design areas, and introduce some derived design parameters. So in this case here, some of the design parameters for my client were a maximum gradient of 18 degrees, generally an average of 15 degrees. I couldn't be at 18 degrees for more than 20 metres before petering out at 15 degrees to step it down. And as I mentioned before, I had to meet a water storage compliance criteria of 960 cubic metres per hectare. Additionally, I had to take into consideration the machine limitations, so that would be the dozers and the scrapers that were used to do the rehabilitation. And the criteria was a geomorphic design that looked as natural as possible. Okay, so after I've generated my 2 metre contours, I'll create a 6 metre buffer around the edge of the tree line using the tree line area feature. I'll generally place that on a 1 in 10 camber, so 6 metres at 0.6 metre crossfall. From there I'll generate a DSM for it, and you can see that in cross section here. So roughly a 6 metre wide track for the scrapers to run on a 1 in 10 camber, and that's to keep the water from running outside of the pit. And you can see that running the full perimeter. Next I'll generate contours for the 6 metre buffer. I'll use that as a point to tie into the tree line on both sides for my designs. So in this case here, I'll start digitizing just to give you an example. I'll generally define my rehab boundary. In this case I've digitized it along the edge of the rehabilitation that I intend to tie into, and then join it back into my tree line around the periphery. Once I've done that, I'll start my digitizing. To give you an example of what it will ultimately look like when overlaid with the design, I'll start somewhere along an existing contour and tie it into the new design. So in this case here, You can see I've tied this one in along here, for example, just using a standard line feature, and I'll just create a new layer. And I'll just start working my way along. And I'm going to use that area boundary to crop at the end. Now, they might look a bit clunky initially, and you might wish to change them. And a good way to do that is to use the vertex editing tool. So if you select the line feature, use the vertex editing tool, you can actually insert vertices, or in this case here, generally what I'll use is the smooth function, and that seems to apply a spline to it, makes it look a bit more natural. If you need more points within, you can also use the crop combine and resample it. You might like to place a point every 5 meters, and you can see it's add some additional points, and then when reusing the smooth function, it once again makes it look even more natural again. So I'll simply start working my way down the hill, tying into the existing rehabilitation, and if I intend to modify the actuals a little, just simply tie them into the tree line. And as I mentioned before, I'll just simply resample these, place a vertex every 5 meters if I want to smooth it out, and just keep working my way down the hill. I'll be checking these in cross section as I'm going, just to ensure that I'm not exceeding the design tolerances. And as you can see, alternatively, you can use the offset function. So when creating these, you can select one of the contours if you wish to use that to project batters down, and you can simply use the buffer area tool as well. So in this case here, I might have a particular contour that I'm working on. That one there might be the 280 contour, and I might project it down to the 278 contour. And by cross-referencing a gradient offset sheet, I can simply project that down at 2 meter increments at whatever offset applies to the vertical offset. So in this case here, I might go fixed distance of 5 meters for 2 meters. Gives me a starting point to work along, and then I can simply use that as a template to design to, and to tie my contours into. And once again, selecting that contour, I can just smooth it out again. So ultimately, I'll start working my way down the hill and eventually define my my bowls, and ultimately I'll end up with something similar to what you can see here. Now once I've finished my design, and I'll create a DSM from it. In this case here, I've already pre-made the DSM. Global Mapper's got some great gradient shaders, so I've got a custom rehab gradient shader which I use to check the rehabilitation gradient. And you can customize these to suit. So in this case, I've got everything over 16 degrees is going to show up red. Everything below 16 degrees is going to be orange, and anything down below 10 degrees blue and below 5 degrees light blue. So it's a very quick way of checking to see if you've exceeded your design gradient criteria. And I can just go back and tweak a few of these lines where they're red. Really easy way to balance your cut fill by pushing your contours up or down. And very fast way of designing. Okay, now I'm going to show you how to create a heat map for your surface analysis. So generally I use a heat map to visualize my rehabilitation for cut and fill. To define the cut and fill areas, I'll create an XYZ file for my cut and fill depths, and I can export these out into a global mapper mobile file for use in field. It's very handy for supervisors or operators for a gross error check to see how deep they've got to dig or how much extra work needs to be done, especially if you don't have fleet monitoring systems on your machinery or high precision GPS on your machinery, or if a surveyor isn't available to physically peg it in the field. Generally I find Global Mapper Mobile is good to within a couple of metres, and if you've got Global Mapper Mobile Pro, you can feed an N-trip correction into your mobile phone, which will give you around about 0.2 to 0.3 metre accuracy, which is more than sufficient for bulk earthworks. Okay, once you're happy with your design and you want to create a heat map, just to do a cut and fill heat map check, Global Mapper's got some great shaders, and you can customise them to suit. I've got a custom shader I generally use, and you can use your design area feature boundary by simply using the combined compare terrain option. You can create a heat map, cut fill, and depending on which way you want to select it, generally you can select your post mining surface versus your rehab design, crop it to your selected area features, and it will do a very quick combination of cut fill for you. You can do it either way depending on which way you want to visualize it. You can have the surface on the top with your post mining below, and it'll give you two different visualization tools. These are very handy. You can actually export these out. A lot of people aren't aware of that, but you can export these out in XYZ files. So for example, if you select layer, export layer, select the one that you want to export it out, and you can export it out in an XYZ file on grid. So for example, I might choose to select a point every 15 meters within that heat map, and use the select area feature. I can select the name of the file. In this case here, I'm just going to call it a cut fill XYZ file, and relative to the design surface and void, and we'll export that out and bring it back in. Now in doing that, simply drag and drop it back in, select it as a point import, select your projection, and you'll come in as a series of dots on screen. Simply double clicking on the point file, we can change the colours very quickly, and select the font we want to see. In this case I'll just make it white to make it easy to see, and select OK, and under labels we can just change it to elevation, and I'm just going to make it 1 decimal place. So in this case here we can see the relative depth that we need to cut where it ties in along the edge of the existing rehabilitation. It's within 100 mil or blue. Everything in red needs to be cut, and there's the areas where the ponds need to go, and this particular roll's got to be moved. Post mining, all of this fill rock material needs to be filled back in with suitable material types, and the lower pond itself needs to be excavated out up to 3.5 metres. That's a really good way of visualising what you need to do. And as I said before, these can be exported out in a Global Mapper mobile format by simply selecting File, Export, Global Mapper mobile file, selecting OK. We can save this in geographical latitude longitude WGS84 format. Generally I like to maintain the existing features, and you can just simply select it and window over the area of interest. We can call that just a GM mobile file, and you'll see how quickly this exports it out. So that's ready to go, and simply grab that file, drop it into an email, send it to your mobile device, whether it be mobile phone or tablet, and you can open up your Global Mapper mobile app and just select that file, and it'll give you full visualization, the same as you see it here on the screen. Fantastic tool I use quite regularly. Okay, now we're going to create a haul road using the pit void shell within Global Mapper. We're going to use the cross-section analysis tool to define the haul road requirements to get from the top of the pit down to the bottom. We're going to establish the gradient that's required, and from that we're going to use the paint tool to create a haul road of sufficient width with the relevant batter gradients, and then we're going to establish cross sections from those, export out the cross sections for use in high precision GPS or fleet monitoring systems. Okay, in this case here we're going to use the cross-section analysis tool to determine the haul road gradient that we're going to need to create for us to access this steep pit. So we've got a current track running around the side of the pit. We want to join into that and run it down to the bottom of the designer pit void. So in this case I'm just going to use select the cross-section analysis tool. I'm going to pick a path roughly down towards the bottom of the pit that I think I might need to go to get down to the deepest point. Change my settings back to non-perpendicular, and in this case here I can see if I run the road from around about here, I can run it approximately down to here at a 1 in 10 gradient before it becomes too steep. In this case I might redo my my gradient. Looks a bit steep for there, but ultimately that might be a better direction there. So in this case here I can run it at negative 9.8%. I know the fleet's maximum gradient is 10%, so in this case I'm going to create a line from the subpath. I'm just going to call that my center line. Bring that back up to my working folder. Okay, it was negative 9.8%. I'll turn my center line back on. In this case I'm going to apply elevations to the selected using the terrain layers. If I double click on those you'll see that they both got vertices at the moment. I can then use the paint tool and using my DSM demo surface, I'll change this to using the selected features, sloping the terrain along the line. We create a 25 metre wide haul road with 1 in 3 batters, and in this case here I'm going to be going negative 9.8%. And I'm going to select paint. And there we have it. Very, very quick. So look at it in 3D. Just turn off those background features to speed up my render. And as you can see, I've got a haul road that peters out roughly at ground level. Now I can tweak these last few points on the vertices to get it all smoothed out, but ultimately the bulk of my haul road design is done within a matter of seconds. And you can see it run in from the top here. The dozer can very easily clean that up. Now from that I'm going to create some center lines and subsequent cross sections. So whilst I've got my point selected, I'm going to use the cross section analysis tool again. I'm going to extend it beyond my centerline points because I want it to blend in either side. And now I'm going to turn on my perpendicular display. I'm going to have it every 35 metres either side of the centre line, and every 10 metres. Now I should be able to step through my cross sections using the step tool, and effectively you can see what the haul road is going to look like in cross section all the way down to the bottom. Once I get to my bottom now, I can very quickly save those and export them out, and I'm going to select all cross profiles, and I very quickly have all of my cross section profiles available to me in my list and display here, and I can look at those in 3D. And then you can see they're all draped to the terrain. I can export those out for alternate software or drafting, or I can simply upload them to HP GPS on machinery to create a design file for a dozer to cut and fill that haul road.